Welcome you all to my channel. This channel is for ICSE class 8, 9, 10 physics. In this channel, you'll get all the video based on the syllabus of ICSE. Today, in this video, I am going to analyze a topic of class 9, motion. In this, I'll discuss different terms of motion, their difference and their relations. So let's start today's topic of discussion, motion. Motion, different types. Motion that may be periodic, rectilinear, curvilinear, translational, circulatory, vibratory, oscillatory, different types of motion. What you read in class 6 and 7. In this, we'll discuss different terms related to this motion. So before going to this motion, first thing we have to know about the quantities. So physical quantities are that quantities which can be measured directly by any instrument or that can be derived by using other quantities. So this physical quantity again divided into two categories. One is a scalar quantity, one is the vector quantities. So first one, if we look at the scalar quantity, in scalar quantity, that physical quantity which is having only magnitude but not depending upon any direction, like the mass. Mass is having only magnitude, means the amount, but not depending upon the direction, like distance, not depending upon any direction. So that time we can say M as the scalar quantity. So in scalar quantity we will get mass, length, work, power, all these in the category of scalar quantity which is not depending on the direction. But when it comes to the vector quantities are that quantities which are having the magnitude, means having some amount with certain direction. When direction specified, that is vector quantity. So whenever we are going in a definite direction, or body is moving in a definite direction, or force is acting in a particular direction, that time it is a vector quantity. For that reason, displacement, velocity, acceleration, weight, all these in the category of vector quantity. So whatever the quantity we have, depending upon the fact that they depend upon direction or not, one is scalar quantity, another is vector quantity. So next is the point of discussion is the topic of today's one, rest and motion. Rest and motion, two terms. Whenever a body is not changing its position, means if I am standing here now and after 10 minutes also I am standing in the same place, my body is said to be at rest. Means when a body is not changing its initial position with respect to time, with the change in time, that is rest. But when you come to motion, when a body changes position, means from one point, if a body is moving to other point with respect to time, with the change in time, when a body is changing its position, that what we can say is the motion. But this rest and motion again relative term. First, let to come to this rest and motion. If we look here, a body is said to be at rest if its position does not change, means it is fixed. And motion time if the body is changing its position with respect to the surrounding. But rest and motion are relative to each other, means a body can be at rest and motion at the same time. Means when we are going in a train or when we are traveling in a train from one place to another, who are inside the train, the passenger inside the train, for each other they are at rest. But who are observing them from outside, for them they are in motion. Means we all are in the rest and motion at the same time, because there is no object in the universe which is in complete rest position. Means all are in motion. So we are in the rest and motion at the same time, but depending upon the point of reference, depending upon the observer, the body can be said as rest or motion. Next one, if we look here, one-dimensional motion. Motion can be shown by a graph which is having three coordinates, x, y and z. But when body is moving in a one direction, that is one dimensional motion. Means when a body is moved along a straight path, or when a body is moving in a straight line, that what you can say is the one dimensional motion, one directional motion, only one direction, either east, west, south, north, up, down, anywhere. So if it is going in a specific direction, in one direction, that what you can say the one dimensional motion. Motion means body is changing the position. One dimensional means one direction. If we look here, that car is moving now from one side to another in a straight path. So that's what you can say as a one-dimensional motion. This motion or the distance changed by the car with respect to the time is shown here. Next one, it is motion and rest are related, because we all are thinking that inside the earth or on the earth surface where we are living, we all are at rest, but earth is having its own rotation and revolution. That means the object inside earth all are having the rotation and revolution. That means we are in the rest position also in compared to the reference, in compared to our surrounding. But when we take or when any of person is observing us from space, that time we all are in motion, means motion and rest are two relative terms. Next one, here you can see distance and displacement. Distance means whenever body start moving, whenever body is changing its position from initial point from which it started to a point up to which it will reach. So in that gap, how much the length covered, that is distance. So distance is the total movement of an object without any regard of direction, means without specifying the direction, without saying the direction, when a body is changing its position from one point to another, initial point to final, that length is called the distance. Distance will show us how much ground cover, how much length cover, and how much distance cover. So, from starting to ending point of the journey, how much the length, that distance will specify us. Another one, it will come to displacement. Displacement is the minimum distance between the starting point and final point, or initial point and final point. Or displacement is a perpendicular distance between the starting point and the end point, because perpendicular distance always the smallest distance. If we look here, home to school, we are having three paths. First one green color, another one red color, and third one the blue color. This blue arrow shows the displacement because it is the shortest path, the straight way from home to school. But we can take any path either in the green color side or in the red color side. That both are the distance. Distance can no need to specify any direction, but in case of displacement, home to school if we look, that is a straight line given an arrow. So arrow always shows for vector quantities for to specify their direction, but for scalar quantity there is no need of any arrow, because there is no need of any direction, because they are not depending upon any direction. It will come to the difference between distance and displacement. Distance is the actual path covered. Displacement is the shortest distance. Distance between 2 points, depending upon which path we have choose. Means we can go with the long way, we can go with the short way, but displacement always the shortest path. Displacement can be zero, but distance cannot be zero. Zero in which condition displacement zero? Displacement, if a body will start from one point and will go to another, let it be a body will start from A point, will go to B, again from B will return to A. That time displacement is zero, but distance is not zero. When a body is in a circular path, that time starting point and end point is same. So because their starting point and end point is same, the displacement is zero, but distance is not zero. Distance here, the circumference of the circle. When the path covered by the body is the distance, but displacement can be zero. Distance is a scalar quantity where displacement is a vector quantity. Distance never decrease. Distance never negative, but displacement can be zero, can be negative, can be positive. So this is the difference. difference between distance and displacement. We'll come to the next one, speed. How much the path covered by any object in a given period of time, in a certain period of time, in a unit time, that's what you can say the speed. Speed is the distance by time. Speed is the distance covered per unit time. Speed will say us how much fast or slow a body is moving. A body is moving fast means it will cover now more distance in less time. If body is moving slow means it will cover now less distance in more time. Another one here you can see instantaneous speed. Instantaneous speed means this one. Here you can see the term instantaneous speed. That means at a particular instant, at a particular point, how much the speed of the body. That is instantaneous speed. When a body is moving from one part to another, any point, any time it will take how much the speed of the body. That is instantaneous speed. But when you come to the average speed, average speed means the total distance covered by total time taken. Means if I am going from here or if a bus is traveling from Balangir to Bhubaneswar, which is a 400 kilometer nearly. For this 400 kilometer, if the bus took 8 hours, that means how much the speed? 400 kilometer by 8 hours. In that 8 hour, speed of bus sometime increase, sometime decrease because it is not constant, it is not uniform, but still we are taking the average 400 by 8 equal to 50 km per hour. That's the speed of this bus. Constant speed means when a body is moving in a path without changing its speed. That is the constant speed. So in constant speed, speed does not change. Speed always remain constant. So whenever we'll take speed is the distance travel per unit time. You can see the speed one. Speed is scalar quantity. Speed is not depending upon any direction. Speed having the formula distance by time. So because it is having the formula distance by time, so it is having the SI unit meter per second or it is having the unit kilometer per hour. And if we will come to the relationship between meter per second and kilometer per hour, here you can see 1 kilometer per hour equal to 1 kilometer by 1 hour. 1 kilometer equal to again 1000 meter and 1 hour 3600 second. So if we'll simplify them, we'll get 5 by 18 meter per second. So we can convert kilometer per hour to meter per second by multiplying 5 by 18. Same way, 1 meter per second equal to 18 by 5 kilometer per hour. Here, one more is the uniform speed. Uniform speed means if the speed of a body remains same, or simply you can say it will cover equal distance in equal interval of time. That means 2 meter in 1 second, 4 meter in 2 second, 6 meter in 3 seconds. So that is the uniform speed. But when it will cover on equal distance in equal interval of time, what you can say as the non-uniform speed. So speed can be uniform, speed can be non-uniform, speed can be constant, speed can be variable. Constant means it will remain same. So one more term used in the motion is the velocity. What you can say the velocity. We got now distance by time is the speed. But when it come to displacement by time or distance per unit time in a specific direction or given direction, that what you can say the velocity. Velocity depending upon the direction. Velocity is a vector quantity. Velocity having again different types means one is instantaneous velocity means in a particular instant of time at a particular point of time how much the velocity of the body that what you can say instantaneous velocity. When you come to average velocity, total displacement by total time is the average velocity. Average velocity can be zero but average speed cannot be zero. Here you will see the unit of velocity same as our speed meter per second and kilometer per hour. In this velocity also we'll get two type. One the uniform velocity when a body travel equal distance at equal interval of time in a given direction, particular direction. That what you can say the uniform velocity. But when the direction change, when a body is changing or when a body is traveling on equal distance, equal interval of time or equal distance on equal interval of time, so that is non-uniform velocity. We'll get the constant velocity also, where the velocity remains constant from one point to another. So now we got two terms, speed and velocity. We'll come to their difference. Speed is defined as the rate of change of distance, but that case of velocity is a displacement. Rate of change of displacement is called velocity. Same way it will come to speed. Speed is a scalar quantity, but velocity is a vector quantity. Speed can never become negative or zero, but velocity can be negative, can be zero. And speed is not depending upon any direction, whereas velocity is depending upon a direction. We have to specify the direction. Both are denoted by letter V, but speed time only V. But in case of velocity, V with one arrow. Arrow shows the direction. Arrow shows it is a vector quantity. Speed may not be equal to velocity, and velocity different for different direction with the same speed. When a body is moving in a circular path, it is having constant speed, or that it is moving in a circular path, but because at every point direction of motion is different, for that it is having velocity different. For that it is a variable velocity with constant speed. That also possible. Now another term used in our motion, that is acceleration. You might have seen in scooty, bike, car, bus, truck, we are using accelerator. Accelerator main work to increase the velocity, increase the speed in a given direction. Accelerator is used to increase the speed. Acceleration is a term used to calculate the change in velocity. Change in velocity per unit time. Increase change means either increase or decrease. Means when vehicle is moving from one part to another, in the middle speed breaker came or any object came in the middle. So has to give the brake in between the initial point to final point. If anywhere any obstacle came, so driver has to apply the brake. At time speed decrease. Speed may increase or decrease with a particular time. That is acceleration. An object whose velocity change over a time interval is acceleration. Acceleration denoted by the letter A. Acceleration can be positive, can be negative. Acceleration depending upon the direction, depending upon velocity, or the unit is a vector quantity. It is also called non-uniform motion because object's speed or direction is changing. It means whenever object's speed or direction will change, it's a non-uniform motion. And when velocity decrease, acceleration negative. When velocity increase, acceleration positive. For that, on one side means when you are applying the brake, your speed change, speed decrease. For that, acceleration negative. But when you are increasing the speed, that time acceleration positive. So when you come to the acceleration, change in velocity by time. Here, change in velocity means by the initial velocity, by the final velocity. Final means how much is attained. Initial means how much is starting. A body moving with a speed, that is initial. A body attained a speed, that is final. Final velocity minus initial velocity is the change in velocity. So change in velocity by time will get the acceleration. So we will come to their unit. First thing to look at the mathematical expression now. Mathematical expression for this is acceleration equal to v minus u by t. V final velocity, U initial velocity, V minus U by T. In this, to change the speed or change its velocity, how much time required? That is T. So it will come to the positive or negative value. If V is greater than U, acceleration positive because V minus U positive answer will get. If V is less than U, will get the negative. And negative acceleration is known as retardation. And it will come to the unit V minus U is the speed, so meter per second by time, so meter per second square is the unit of acceleration. So acceleration can be positive, can be negative. Here, if we look uniform acceleration. Acceleration is said to be uniform. Uniform in each time will say when equal change in velocity takes place in equal interval of time. Means velocity 2 meter per second change in 1 second, 4 meter per second change in 2 seconds. Means the equal interval of time with the if the velocity change equal, equally, that is uniform. But when it comes to non-uniform, in non-uniform time, same interval of time, unequal change in velocity, or equal change in velocity in not in the same interval of time. That's what you can say non-uniform acceleration. So one is uniform acceleration, one is non-uniform acceleration. So one more term used is the acceleration due to gravity. Whenever a body is coming from the height up to down, because of force of gravity, because of force of attraction by a heavenly body like Earth, the velocity change by the body with respect to time is the acceleration due to gravity. So, acceleration due to gravity is the acceleration gained by any object, or the speed changed by any object with a certain period of time in a particular time by the gravitational force of attraction. That what you can say is the acceleration due to gravity. Gravitational force is the non-contact force which is always attractive in nature, which always attract any object. So acceleration due to gravity, acceleration produced by the force of gravity or gravitational force. And its SI unit same like the acceleration, meter per second square, and acceleration due to gravity having both magnitude and direction. So it's a vector quantity. Like acceleration is a vector quantity, acceleration due to gravity also a vector quantity. And its value, if we look on the Earth's surface, average value is 9.8 meter per second square, and acceleration due to gravity represented by small g. Acceleration due to gravity used to calculate weight of a body, weight equal to mass into acceleration due to gravity. So this all term, distance, displacement, speed, velocity, acceleration, all this use motion. This is the fundamental concept of motion. In my next video, I'll come near you with the graphical representation of a motion, where you will get displacement time graph, velocity time graph, and acceleration time graph. Mean the variation of displacement with time, velocity with time, and acceleration with time. For this, what you have to do? You have to subscribe my channel. You have to like the video. If you feel it is helpful for you, you have to give your valuable comments in the comment box, and don't forget to click on the bell icon to get the further notification. Thank you.